So this is a brief demonstration of the energy distribution model that's new in Rubicon version 6. So if we go to the Tools menu and open the energy distribution model dialog, you can see that as soon as we do that, we see this rendering of the energy heat map in the viewport. So we can see this in both the section view and the 3D view. And obviously in the section view, it will show you that heat map based on the section that you're looking at. Now in the 3D viewport, things are a little bit different, because obviously we're not looking at any particular section, we kind of have them all in view. Now, so to control that, we have this position along slider. Now, if you just drag that around, you can see that that heat map updates pretty much instantaneously based on the position of the slider, which controls where along the drive that heat map's getting rendered from. So right here, for example, you can kind of see that this one, we sort of drag it to there-ish. You can see that it's right between this ring section and that ring section over there. So you can see the depth right there, or the chainage along the drive there. We're at sort of 10.23 meters, and you can type in an exact number if you know exactly where you want to look at. Obviously, we can check out the where these ring sections fall. So this goes at 11.6, this goes at 8.7, so 10.23 somewhere in the middle. Now I'm just going to, you can see that it's a little bit difficult to see with all the holes in the way, especially if we're far back. So I'm going to click on this Hide All Rings button here. So that'll just temporarily turn off all of our rings, changes the visibility of all the rings there to false, so we can see this heat map a lot more easily. Now we can also change the render plane axis from section to plan or to side. Now obviously the plan view will give us sort of a top-down rendering of that heat map, and you can see that now the slider will take us sort of from top to bottom or bottom to top. And again, we can type in a particular RL there if we need to. Or if we go to the side view, again that takes us sort of from the left side of the drive of the design to the right side. And again, there's our offset value right there. So you can pretty quickly get a good overview of how all the energy is distributed in your design just by dragging these sliders around and looking at the different cross sections of the design. So right here, for example, sort of back here, we start getting kind of a lot of blue over here, which is a fair way away from our footwall there. Some more blue there. It even goes transparent for a bit. So you can pretty quickly identify where problem areas might be. Now there's a couple of other settings in the dialog box here. Now there's this ramp colors tab. We can go and change how the different colors get represented, and you can see exactly what the different colors define. So our blue values here define anything of a powder factor of 0.5 grams per cubic centimeter or below, going all the way down to 0.1, which is fully transparent. So anything below 0.1 is completely transparent. So over here where you can see that it's very, very faintly blue, that's going to be somewhere around sort of just a bit over 0.1. All the way up to white, which you can see sort of right in the middle of the holes there, is sort of 25 or over. Now, if you need to add colors, you can just add a color really easily. If you want something really bright pink at 50, so you can see exactly where those really high energy zones are. You can do that. You can delete colors, so you can easily change exactly how that heat map's rendering and figure out exactly what those colors are defining. Back in the render settings, we've got the resolution. Now, obviously, this changes how fine the heat map renders at. So right now it defaults to 0.25 meters. So that means that one sample is taken every 0.25 meters in this particular example. So you can see that that's a pretty good, a pretty decent resolution. It certainly gives you enough information about the energy distribution to sort of make informed decisions. But you can obviously crank that up if you need more resolution, or crank it down if you think you've got too much. This should render fairly well on most machines, I think. So a couple of other things. The ignore threshold, basically this just defines how far away from a point needs to be for the renderer to completely ignore it. So basically any point that's further than 10 meters from a hole will just ignore any contributions from that hole. Now by default, this sum contributions attribute is turned off. What this means is you probably can't see the tooltip, it probably goes off screen there. But basically what it says is if this is turned on, then contributions from any hole within this radius is added together, and that generally results in a much brighter heat map like this. If you turn that off, which it defaults to, then it only shows you the highest contributor at any point. So you can kind of see, this particular point right here is white, and it's only going to be taking contributions from the hole that's right there. Now, probably about the only other thing to say is if we turn our rings back on here, let's change this to section because it makes it a little bit easier to see. Oops. So if I go to the first ring here and grab this hole, like just about anything in Rubicon, this is completely live. So if I drag this hole around, you can see that heat map is updating. So when you see problems in that energy distribution, you can pretty quickly jump in there and change things around to see how you might be able to rectify those problems. Sorry, lastly, there's this the copy to clipboard will basically take a snapshot of whatever is rendered on screen at the moment, and it'll copy that image to the clipboard, and then you can go and paste that into a report, or into an email, or into whatever else you need to paste it into. That's about it. Thanks for listening.